Okay. Hey, I'm alive. Hello, NDC Oslo. Have you had a great week? Let's come on. I know you're Norwegian, but you can make a bit of noise. All right. It's been fantastic. It's been sold out last year. It was kind of about 2/3 full. So we are back to full strength. I have had a fantastic week, met a bunch of people. I liked 2 of them, which was nice. Before I start this, I just want to get everyone, there's a lot of work that goes into this. So to start off with, there's the NDC crew, Jacob, Chesty, Steiner, Henriette, all those guys who plan these things and work out the agenda and everything. So let's have a round of applause for the NDC crew. And then there are all these people around the edge of the room who've been working hard, keeping us fed all week, just from the start of the conference to the end, all this delicious food. So let's have a round of applause for the caterers. And then I have to do this because otherwise he'll cut my mic off. There's the technical people who've been doing the cameras and the screens and the audio and all that sort of stuff. So round of applause for them. And of course, all these people on the expo floor, all the sponsors, all the people with stands, without whom your ticket would have cost 3 times as much and your company would never have paid for it. So round of applause for the sponsors. And then there's a whole bunch of volunteers who've been scanning badges and all that sort of stuff, and probably some other people I've forgotten, the security people, all that sort of thing. So round of applause for everybody else. And then at this point, some people would say, and give yourselves a round of applause, but I don't understand that, you know. You've come here, you've had a great time. Why does that get... No, give yourselves a round of applause for turning up as well. So, I am here to finish off. You're all exhausted. You've had lots of technical content. You've been taught how to do microservices properly, and then someone else saying, no, that's not how you do microservices properly. This is how, and other things. And so the last slot, they finally just went, you know what, sod it, we'll just let Mark do his thing on the main stage. Yay. So I am just going to basically talk bollocks. I might accidentally teach you something, for which I apologize in advance. But this is weird. I've got people behind me. It's like, yeah, okay, fine. So yes, but we're going to talk about some of the greatest mistakes in the history of programming. And I just want to clarify at the start. So first thing, I'm probably going to swear because it's live streaming on NDC Conference's YouTube channel, so that'll probably get a strike against them, so that's fun. But if you are sensitive to bad language, you should probably just fuck off now. I'm going to talk about mistakes, but I'm not going to talk about anything that, any sort of software errors that have killed people, because that's not funny. But just do bear in mind that software has killed people in the past. I'm also not going to talk about any aeroplane stuff, because I'm aware that quite a lot of people are going to be going straight to the airport from here, and you don't need to hear about that. So, yeah. Speaking of mistakes, so I did this talk at NDC Copenhagen earlier this year, and it went up on YouTube. And so I would just like to thank all these people on YouTube for finding the mistakes in that version of the talk, which I have fixed in this version of the talk. So thank you very much, YouTube people. Just to make this fair, because, you know, I am in no way blameless, I want to talk about one of the mistakes I have made in my career as a programmer, which is now 33 years and counting. And it's the medfile unfucker. So, I think I was 27, 28, and I worked at a company, and we had a piece of software that did very complicated queries, and you could save these queries out as a file with a .med extension. I can't remember what MED stood for. And we released a version of this software that corrupted those files, but it corrupted them in a reversible way. I think somebody spelled a field name wrong or something. And so the support chap came to me and said, Mark, the med files are fucked. Can you do something to fix them? And I went, you want me to write something to unfuck the med files? And he said, yes. And so I booted up Visual Basic 6. That was not the mistake, that was just a mistake. So I booted up Visual Basic 6, and I created this little standalone application, and I honestly can't tell you why I did this at the time, but I called it Medfile Unfucker. And so it brought up a little dialog box that had a file selection thing, and the label on that said, choose file to unfuck. And you clicked it, and you browsed, and you found your med file, and then there was a big button at the bottom of the dialog that said, unfuck now. And you clicked that, and then it did the thing, and then it popped up a message box saying, med file successfully unfucked. And so I gave this to the support guy and said, there you go, just test that, make sure it works. And he heard that as, please release this to the customer immediately. In my defense, the file was called medfileunfucker.exe. So, you know, he obviously didn't even look at the file name. So yeah, that was an interesting one. The customer was not happy. And I somehow managed to keep my job, basically because I was the only person in the company who could do things like write medfile unfuckers. But I did not get a good performance review that year. Okay, let's move on to some more kind of global mistakes with a higher price attached to them. And obviously one of those is Y2K. So I'm 50 years old next birthday. I was actually there, and I had to do some of the stuff to fix the Y2K bug. And we all worked incredibly hard on it. And then we got through the millennium, and nothing happened. And people went, oh, that was a lot of fuss about nothing. And yeah, thanks, everyone. But so the Y2K bug, the thing is, to understand the Y2K bug, you have to remember what computer software was like in the 1950s and 60s, because that's when it started. So data was stored on punch cards, and like each column of that punch card is 1 byte of data. And so this was a very expensive way to store data. And while it was actually in the computer and it was being worked on, computers in those days used magnetic core memory. This was amazing stuff. So every one of those pins has got 2 wires running through it. And they were actually made by hand, mostly by women with microscopes, passing these wires through these pins. And the cost of magnetic core memory in the early days was about $1 per bit. So a byte cost you $8. And so it was important to use as few bytes as possible. And so the standard date type in COBOL, which was the language of the time, was a PIC9 of 6. That's a number with 6 digits, 6 bytes, because that saved $16 in memory space. And if you've got a whole sort of day's run of stock trading or sales for Walmart or whatever going through your system, that's a lot of dollars that you're saving. Also, it was the 1950s. So the year 2000, there's no way people were still going to be using your COBOL software in the year 2000. Is it been replaced by then, won't it? Yes, of course it will. If not, then Mark and a bunch of other idiots will come along and fix it. I learned COBOL just enough to go through and change all those PIC9 6s to PIC9 8s, and then try and fix the underlying DB2 things. But this is Bob Beamer. And Bob Beamer in 1958 was going, hey, this is going to be a problem. And I know that we can't do anything about it now. I'm just raising it. And can we put like an item in the backlog for when we invent Agile? to fix the Y2K bug when we can do it in a nice, relaxed, and not crunchy kind of way. And then in 1968, he went, I noticed we're still not talking about the Y2K thing. And in 1978, he said, I noticed we're still not talking about the Y2K thing. In 1988, people started going, oh, we should probably start thinking about that Y2K thing. It was actually like 1995 before the newspapers got hold of this idea of a Y2K bug. And then all the companies were like, shit, we actually need to fix this now. And so people who still knew COBOL at that time, who had retired 20 years previously, were getting phone calls going, how much would you charge to come and do this? And they went, oh, I don't know, 20,000 a day? Maybe? Yeah, that should do it. And so estimates of how much the Y2K bug ended up costing are they vary. But the middle of it is about $500 billion was spent fixing the Y2K bug. And some of that code that was being fixed had been written in like 1992, 93. So people were still writing new code with the Y2K bug in it. And so you'd think we'd learn from that, and we wouldn't do that again, would we? So this year, there was actually a Y2K22 bug with Microsoft Exchange. You probably remember this showing up in the log files of Exchange because it was using a 32-bit integer to represent dates or something, and it couldn't convert 2201010001, which is actually obviously the date just formatted as YYYYMMDDD or something, and then put into an integer for some reason. So as soon as it went to 22 at the start, that doesn't fit in an integer. Signed integer, obviously. And so that went wrong as well. There's Y2K38, or the Apocalypse, which is the Linux problem, where they were using a signed 32-bit integer to represent the date and time. They've now switched to a signed 64-bit integer, which should take us up to, well, we're all going to be dead. Like the entire human race. The sun will have expanded and absorbed the Earth, and we will still be on it because Elon Musk will have died, and he's the only person who cares. There's a fantastic one, though, that I found out about from a YouTube channel called Stand Up Maths while I was researching this talk. The Kennel Club of the United States of America have a Dog 38 bug. So when you register your dog with the Kennel Club, your pure breed Shih Tzu or whatever it might be, they have a dog with your dog's show name and the breed, and then if there's already another one, then your dog becomes number 2, and number 3, and number 4, and number 5, and so on, until you get to dog 38, and then you try to insert that into the database, and it crashes. Can anybody guess why it crashes on the number 38? How do you think they are storing that number in the database? Roman numerals. Correct. Every number up to 37 fits into 6 Roman numerals. So the field that stores the dog number in the database is not an integer, it is a char6. And so when you get to 38, which is XXXVIII, as opposed to like XXXIIX, which would have made sense, then that's it. It dies, it chokes, you can't put your dog in. You can put dog 39 in, though, because that goes back to just being XXXIX. So yeah. All right. Moving on from Y2K, but in a kind of related way, because these were the people who caused and suffered from the Y2K bug, we have enterprise software development. Because, yeah, it's a mistake. I don't like doing the dictionary thing, but the dictionary enterprise, a business plan or project, especially one that is difficult or that may fail or lose money. And you sort of think, yes, it's more likely to fail or lose money because of enterprise software patterns and practices. No offense, Microsoft. This is an enterprise agile software development model. This is safe, scaled agile for lean enterprises. So yeah, they sell posters of this that you can buy and put up on the wall of your developer's office because they are that proud of it. And there were YouTube comments going, oh, I was with him until he knocked safe and then I lost interest. There's nothing wrong with safe, it's perfectly good. So yeah, I'm not drilling into that any further than I have to. This is Auto Scrum 1.1. This is Accenture's version of Scrum. So, I know Scrum as 5 arrows going round in a circle, and that's it. But no, Accenture, this is their version of Scrum. I don't even want to know. And then, you might actually have seen this one because it was quite popular at the time. This is Deloitte's Agile Landscape Roadmap version 3, where the Scaled Agile Framework for Lean Enterprises and Accenture's Auto Scrum are just one node hidden somewhere on this absolute abomination. And I did experience enterprise software. I mean, I've done enterprise software development, and sometimes it's been super painful, and sometimes it's actually not been too bad. And sometimes you're kind of like, well, yeah, okay, finance software, mission critical systems like running trains and planes and that sort of stuff. Yeah, you need those additional sort of, I shouldn't just be able to deploy to production simply by pushing to a GitHub branch. So you do need some stuff. But back in the mid-noughties, I was working for a company, we did a lot of consulting, and we got a call from one of the UK's kind of non-governmental autonomous agencies, quasi-autonomous non-governmental organization, Quango. That was a word in the noughties. I'm not going to say which one it is, but they had an API endpoint that was unsecured. You could hit it anonymously. It didn't have any IP throttling or anything, so you could hit it as often as you wanted. And the data that it returned was incredibly useful if you were investing in certain futures on the stock market. And so, obviously, all the investment funds and investment banks and everything were just hitting this thing and then not doing a thread.sleep at all, and then just hitting it again. And it kept crashing. About once every 20 minutes, it would crash and reboot because it was a .NET service running an IIS, so the app pool would recycle. And so they hired me to review the code and not fix it. They hired me, they paid me 2 weeks of a very expensive day rate to document what was wrong with the system and how to fix it. And so I went and I got the code and I loaded it up and I had ReSharper installed, and ReSharper burst into tears and uninstalled itself and refused to come out until I made that code go away. And the easiest way to work out how to fix this is to fix it and then tell them what I did. And the primary thing that was causing a problem, slightly technical thing, if you're not a .NET developer, we have this thing in .NET called iDisposable. If a class implements iDisposable, then when you're finished with it, you have to call dispose on it. And this is such a common thing that we have a using statement, so you can put that variable into a using block, and then when that block finishes, it will be disposed. And one of the key things that you always have to do this with is database connection objects, because they're really expensive and there is a limited number of them, and they use a lot of memory. And this application was talking to an Oracle database, and there were about 20 places where they were creating an Oracle DB connection, and in none of them were they disposing of that connection when they were finished with it. So this application was leaking enormous amounts of memory, tying up all the Oracle database connections, and then crashing. That was the point at which these connections got disposed. And so I added using statements to these 20 places, and it fixed it. And then I went through, and it's like, okay, that was 30 minutes. What am I going to do for the next 2 weeks? I'll put using statements on these things. We can't charge them £25,000 for that. So I went through the rest of the code and I found some stuff. But the other thing was, this was a .NET 1.1 system, and it was 32-bit. And this was when .NET 4.0, I think, was the current version, and we had 64-bit servers. And they had it running on a single server. So there was no kind of load balancing or anything like that. So we sent this report back off to them, and I just assumed that they'd read the report and gone, oh, that's easy, and fixed it. 6 months later, we get another reach out from them saying, oh, right, we've set up a meeting with all the stakeholders. Would you mind coming to discuss your report? I'm just kind of like, yeah, okay, we'll come up and discuss the report. So I turn up, and at this point, I discover that these people, all their IT is actually handled and managed by, I won't say the name of the company, but it's 3 letters. And they're the ones after HAL in the alphabet. So me and my boss turn up to this meeting, and there are 8 consultants from this place, consultancy, plus the CEO of the data center where the application is currently hosted, plus the CEO of the data center where it's going to be migrated to, plus 3 of the senior people from the actual organization in question, and probably a couple of others. And they sit down and they go, so this thing about using statements, is that going to cause any changes in the application's behavior? And I said, yes, it won't crash every 20 minutes. And I said, yeah, but could it have any unintended side effects? And I'm like, no, unlike not using them, which causes your application to crash every 20 minutes. And they went, okay, so we'll need to sort of be careful about this because this is a mission critical system. And I said, it's a mission critical system that crashes every 20 minutes. And I said, you know, you could also, if you really wanted to, you could fix this just by buying a new server and running it on that instead and putting like a terabyte of memory in it, and then it would probably only crash every 24 hours. And even in 2005, that server would still cost less than this meeting. And my boss went, Mark, do you want to go outside and get some fresh air? Which meant go and have a cigarette, because I smoked at the time. And I thought, oh, Christ, he's going to be so pissed off. And so I went out and I stood by his car and I'm smoking a cigarette. And then 5 minutes later, he comes out and went, I told them to stuff it, bunch of idiots. So it's unclear how much enterprise software development has cost over the years, but probably trillions of pounds. Actually, probably just the governmental stuff has cost trillions of pounds. So, yeah. All right. The Pentium floating point unit. This was a fun one. You might remember this. So this was the Intel Pentium. The Pentium was the first CPU from Intel where they all had a floating point unit built in. So the 386 and the 486, they had a DX version that had a floating point unit and an SX version that didn't. And you could actually buy an add-on floating point unit for the 386 and the 486 if you decided you wanted it later. But the Pentium had it built in. And they had verified all of the microcode for the Pentium processor actually using Haskell. They write the microcode verification in Haskell. And so they were absolutely convinced that this was all right. And so, you know, it's really hard to fix a bug in a processor. You don't want them. So 4,195,835 divided by 3,145,727 is actually 1.33382. According to the Pentium, it was 1.33374, which you might think sounds like a little thing, and most sums worked, but there were a few like this that didn't. And if you actually needed that number to be right when you ran it through your Pentium using the floating point unit instructions, this was kind of a problem. And so Intel had to go and say, all right, if you are actually hitting this bug, if you can demonstrate that you are hitting this bug, we will replace your Pentium with a new Pentium. And then they had so many people just coming up with ways to say, oh no, I am definitely hitting this bug. They just went, fine, we will just replace all of them at a cost of $475 million. So yeah, that one was fun. All right, null. I mean, everyone knows the value of this. Tony Hoare, the guy who, he invented null, basically. And so these days, when you've got kind of Rust people with their option types and various F# with its maybe and all this kind of thing, going, oh, you just shouldn't have nulls. Nulls were a bad idea in the first place. But Tony Hoare, Sir Charles Anthony Richard Tony Hoare, Fellow of the Royal Society, created Algol W, which was the first language that had records or structs, objects that contained multiple values. And so when you've got a record and then another record has a reference to that record, there is a possibility that it won't be set. So it's like before that, if you had a string that didn't have anything in it, it was just a 0-length string. If you had a number that didn't have anything in it, it was 0. But suddenly you've got this idea of pointers to objects on a heap. And so if you have something and there is no pointer to an object on the heap, back in the late 60s, I think, then you have to have something that can be when it's not set. And so it had the keyword null. It's the first language to have a null keyword. And so it wasn't a mistake at the time, because if you look at things like Rust's option type and so forth, they use more memory. They are more expensive. And so null, just going, well, it's a pointer, so if it's 0, because a pointer is just an integer, so if it's 0, that's a null pointer. It made perfect sense. But he, in a talk that he gave at QCon a few years ago, referred to it as his billion-dollar mistake. And so hands up if you've had something explode in production because of a null reference exception or the equivalent thereof. Undefined has no member length, and so on and so forth. So yeah, that's $1 billion. At least, I would say probably more. Sometimes programming fuck-ups can cause actual physical problems in the real world. So the Hartford Center in the United States was built in the 1970s. And in the 1970s, they had computer-aided design software, but it wasn't like AutoCAD, because we didn't have graphical user interfaces. So computer-aided design software was more like MATLAB without the visualizations. You would put your numbers in, and it would give you numbers out. And it would tell you about the strains and stresses, and it knew about the tensile strengths of various kinds of steel and the load-bearing abilities of L-joists and all this sort of thing. And so somebody used a computer-aided design system and programmed it with all the things necessary to build the Hartford Center's kind of steel infrastructure, and it was good. And so he sent it off to the architects, and the architects sent it to the builders, and the builders put it together, and it was fine, and it hosted lots of events, and it looked great, and everybody loved it. And then it snowed, and this happened, because the person who was doing the software had put in what should have been a horizontal shear force as a vertical shear force. And so when the snow that was on the roof of the Hartford Center slid sideways and created horizontal force, the whole thing just collapsed. So yeah, I've never made an error in an application and then been able to go out and stand in the street and take a photograph of what went wrong because of it. It's on my bucket list. One day, and then I'll come back and I'll tell you all about it. So yeah, that cost $90 million to fix that, to put the roof back on. Fortunately, so there'd been a concert there that evening, but everybody had left the building. There was no one in the building when that happened. Knight Capital. Knight Capital is a hedge fund, and that basically means that they deserved this that I'm about to tell you about. So, because let's just talk about the stock market quickly. The stock market, the Dutch India Trading Company needed to build lots of ships so that they could go and plunder India and steal all its stuff and bring it back and sell it to European people. And so they needed money to build the boats. And so they said, all right, we will sell shares in the company and then use that money to build the boats. And then when we come back and sell the stuff, we will give you your share of the profits that we make from doing this. And then the people who had bought the shares started selling them to each other. And that was how the first stock markets popped up in Amsterdam and or Rotterdam, I think, and Antwerp and places like that. Somehow, 400 years later, that has turned into extremely highly tuned C++ programs operating entirely autonomously on remote servers, doing trades in fractions of a millisecond to try and cream off 0.00001% of the difference in the value of a share from 1 second to the next. And this was happening in 2010, 2011, and these were called dark pools, these places where these automated trading bots effectively would just compete with each other. And so the only thing that people were trying to do was make their bot better than all the other bots. And sometimes that was optimizing it, and sometimes that was improving the algorithms and the predictions and everything. This is a job title, quant. Is there anyone here whose job title is quant, by the way? No one's going to fucking admit it now, are they? So there's all this dark pool trading going on, and the New York Stock Exchange is seeing a downturn in trades going through their systems because all the trading's happening in these dark pools. And so they worked with the SEC, Securities and Exchange Commission, to make these dark pools illegal, but then they created the official dark pool for all these things to run in. And so Knight Capital had a thing that had been running in these dark pools called the Smart Access Routing System Power Peg. And they had 6 weeks to rewrite this software to make it compatible with the New York Stock Exchange's new system. And so obviously they copied and pasted a lot of code. And copying and pasting code may be a theme through some of these remaining mistakes. And so they reused a flag that on their previous system had marked the trade as a test trade. Do not actually run this trade. We're just testing it to see if it's something that we want to put live. And then they shipped it. And they had hired 8 machines in this dark pool running inside the New York Stock Exchange to run this code. And they launched it, and by 9:10 on the morning that they launched it, it had bought $90 million worth of stocks, and it shouldn't have done that. And then they watched it, and by 9:30, it had bought $200 million worth of stocks, and $2 billion worth of stocks, $2 billion. And they went, okay, we haven't got $2 billion. We can't actually settle this at the end of the day. And then they noticed that of the 8 machines they deployed to, 7 of the deployments had worked, and 1 of them hadn't worked. And so they thought, oh, well, it's obviously that one that's causing the problem. And so then they deployed to that one as well, and the problem got worse, so that by 9:45, they spent $4 billion. Turns out that the one that hadn't updated was the only one that didn't have the problem. And so they basically had to shut the thing down, and you have to settle up your trades by the end of the day. And so they had to go begging to Goldman Sachs and say, please give us the money to pay off these trades by the end of the day. Goldman Sachs said, yeah, all right, we'll give you the money, and then we're going to buy your company for $450 million, which is not what they thought it was worth. Like I say, hedge fund totally deserved it. Okay. The title of this next section makes sense if you were a fan of the Muppets in the 1970s. Bugs in space! Yeah, just me. Couple of people. But yes, no, there was a pigs in space thing. I thought that was great, and then I did it in London at the start of this year, and everyone was just like, what? Okay, so let's do this instead. In space, no one can set a breakpoint. So all spacecraft are driven by software since the beginning of spacecraft, because they're too complicated for people to drive, even if there are people on them. But the vast majority of spacecraft don't have people on them because they have a tendency to explode. And people kind of go, I don't want to sit on the top of that enormous stack of very explosive stuff that you've put there. It might explode. And so we have to automate our spacecraft. So one of the earliest examples of this was the Mariner 1 spacecraft, which was supposed to go off and look at planets and send photographs back. And this has been referred to as the most expensive hyphen in history. So this is what Mariner 1 would have looked like had it made it into space. And it had gone off and it would have done a planetary flyby of Venus and taken photographs and sent those back to NASA. Mariner 2 did actually work, but Mariner 1, not so much. And this wasn't actually a programming mistake, it was a specification mistake. So if there are any business analysts in the room, yeah, you don't get off either. You're just as bad as us. This was the bug. So the handwritten guidance equations that somebody had given to the programmer to encode using probably Fortran, I'm guessing, had an R in it, and it should have had a line over the top of it. And the line over the R, so R is for radius, and the line over the R means smoothed over time. So this value is going to go boom, 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 like that. And what your algorithm needs to do is smooth that out and find the midpoint between the highs and the lows. And that's what we want to plot. But it didn't do that because they didn't put the hyphen in there. And so the programmer, who doesn't know anything about guidance systems, they just know how to convert mathematical equations into Fortran, puts the thing in there. And as soon as it started ascending, the booster lost its connection, lost guidance lock with the ground, and the rocket it was on was designed to continue on a pre-programmed course. When the lock was re-established, the faulty guidance logic caused the program to erroneously report that the velocity was fluctuating in an erratic and unpredictable manner, which of course it was, because it was supposed to be smooth and it was jumping up and down all over the place. And so the range safety officer actually pushed a button and blew up the rocket and Mariner 1 along with it at a cost to NASA of $10 million. Which doesn't sound like a lot, but in today's money, that's like 100 million or something. That incident was what led to the creation of software engineering as a discipline. They were kind of like, how can we stop this from happening again? It was a thing where they said, okay, we're going to have clearly defined roles and training and degrees and things that people can go and do in the same way as they would for building a bridge. But it didn't stop them from messing up. So the Mars Climate Orbiter This was supposed to go to Mars, and it was supposed to go into orbit around Mars and monitor the atmosphere and send that data back to NASA so that they could work out how much oxygen and nitrogen and carbon dioxide and all that sort of thing was supposed to be in there. So this is what the Mars Climate Orbiter would have looked like above Mars if it had actually made it. On September the 23rd, 1999, communication with the spacecraft was permanently lost as it went into orbital insertion. The spacecraft encountered Mars on a trajectory that brought it too close to the planet, and it was either destroyed in the atmosphere or escaped the planet's vicinity and entered an orbit around the sun, which would probably have killed it. They don't know. They don't know what happened because they lost telemetry to it, and you can't have a telescope pointed at a tiny little chunk of metal that's supposed to be in orbit around Mars. They have no idea which one of those things happened. It's brilliant. So, what caused that problem? Units. So, the entire world uses the metric system. The metric system is very sensible. Everything is based on kind of one core element. You've got a millimeter, and a kilogram and a litre, and 1 litre of water weighs 1 kilogram, and then you just divide things up by tens and hundreds and thousands and all this sort of stuff, and it's a nice easy system. We've got 10 fingers. If it comes down to it, you can do it on your fingers. Except America, where they use feet and inches and miles and gallons and quarts and all that sort of stuff because they're different. They're not like us. That's all it is. Now, for this system, and actually for all NASA systems at the time, NASA had basically turned around to the United States and said, we're using the metric system. You all can carry on doing whatever you want to do. We are using the metric system from now on. And so all the contractors, there are a lot of contractors involved in building NASA projects, and all the contractors were told, we're using the metric system. And they did across all the code, except one piece of code from Lockheed Martin, which they had copied and pasted from an earlier project, which used feet and inches. And so, unfortunately, this was the piece of software that controlled the orbital insertion of the Mars Climate Orbiter, which meant that, well, just for clarification, if this is a person who is 2 feet tall, no, if this is a person who is 6 feet tall, this is a person who is 6 meters tall. It's quite a big difference. And so when the orbiter came to Mars, its planned trajectory was 226 kilometers above the surface of the planet. It actually came in 57 kilometers above the surface of the planet. NASA have said that we were at fault for failing to make the appropriate checks and tests that would have caught this discrepancy, because you can't slag off Lockheed Martin, because otherwise they'll stop making bombs for you. That won $327 million. So yes, silly Americans blowing up rockets. We would never do that here in Europe. We're much more intelligent than the Americans. Oh no, Ariane 5, the French space company, but basically the European Space Agency. We all cooperate on the Ariane project. So the Ariane 4 had been in service and delivering things to orbit perfectly well for years and years and years. And Ariane 5 was the replacement for the Ariane 4. And this is the launch of the Ariane 4 on the 4th of June, 1996. And everything went absolutely fine. The rockets lit at exactly the right time, and the spacecraft soared majestically into the sky and took off and started heading for orbit. And literally, like the crown heads of Europe and the presidents and the prime ministers and everybody had been invited to the spaceport to view this historic launch. and it shot up into the sky, and it was the most powerful rocket that had ever been built outside of the United States of America, and everyone was really, really excited about it, and it was a striking a blow, and oh shit. Guess. They copied and pasted code from Ariane 4. So they copied and pasted some code, which resulted in them trying to store a 64-bit floating point number in an address that held a 16-bit signed integer, which represented horizontal bias. This caused a processor trap operand error because the floating point value was too large to be represented by a 16-bit integer. And this essentially told the Ariane rocket that something was well out of its operable range and caused its onboard systems to self-destruct the rocket so that they could at least control where the pieces landed, I think. So yes. So they grounded that, and then they fixed it, and they took out the copied and pasted code, and then everything worked at a cost of $500 million. Okay, let's bring it back to something that we can sort of identify. I mean, do people, anyone here work on rocket guidance systems and copy and paste code? Again, no one's going, yeah, I do. Let's bring it back to something that we can all identify with. The big rewrite. So yes, new and improved, new and improved. Oh, we've written this application and we use Angular JS 1.0, and that's old now. We have to rewrite it to use React because Facebook. And so I have been guilty of this. I have learned from my mistakes, and I don't do this anymore. I will finish a system in the language it started in. But back in the day, I was very distracted by shiny things. And actually, the same company where I wrote the med file unfucker, once they'd forgiven me for that, we had our main application was written in something called Gupta SQL Windows. Be like one person maybe in the room who actually has heard of Gupta SQL Windows. Anyone? Yes, there he is. At the back, it's like playing Where's Wally? And yeah, this was not a development platform with a future. And they were like, we need to rewrite it. And .NET had just appeared, and .NET 2.0. And I was kind of like, we should rewrite it in .NET because, you know, we've got some VB stuff and there's Visual Basic .NET, and so we could probably copy some code across, but I'm going to write it in the C#. I'm going to write it in Windows Forms. And so I got permission to go ahead with this, and I started porting this system from Gupta SQL Windows to C# and Windows Forms. And there was me doing that, and there were 4 people maintaining and adding features to the existing software package. And the idea was that because I was a 10x programmer, there was a face that went with that. I was going, people behind me, just in case they think I actually think I'm a 10x programmer. I'm just a 10x idiot. So they went, yeah, you'll be able to catch up with them quite easily. And then eventually it became obvious that that wasn't going to happen, and so they gave me another person to help me, and we were actually catching up, and we were getting there. And then Windows Vista happened, and .NET 3 and 3.5 happened, and WPF happened. And I thought, well, WPF's binding, I had been struggling with the Windows Forms data binding system, and WPF's data binding system. Windows Forms data binding, you couldn't say object.object.object. So you could only have one level of data binding. WPF, you could do ... right down into the thing in violation of the Damocles principle or whatever that is. And so we should basically keep the library code we've written and redo the entire UI in WPF. WPF version 1, by the way, which was not without its issues. And so I decided I was going to do that. We worked on it for a few weeks. Then the programmer that they had given me to help me with this actually quit. And so I was left trying to do it on my own. And by the end of that project, I was working 100 hours a week. I made the company buy me a laptop so I could work on the train on the way in, work through the day, work on the train on the way home, and then carry on working in the evening. 110 hours a week. And then my brain snapped, and I had a complete breakdown. And I went off and I was in hospital for 6 weeks. And they scrapped the project and replaced it with a different project that was all in VB.net and said, you can work on that. And I said, can I fuck? And I quit. So yes, I figure with what they were paying me and the other developer and various other things, that was actually probably about £100,000 down the drain. And of course, my sanity. So yeah. This is a personal bugbear, recursion. Fibonacci sequences and all this sort of stuff. So people, oh, you should use recursion and you should use languages that have tail call optimization to handle your recursion. Because if you do it in a language that doesn't have that, you will get a Stack Overflow exception. You call a method that calls itself, and then it calls itself again, and then it calls itself again. Every time it does one of those calls, it puts the parameters on the stack, and eventually the stack fills up, and your program can literally do nothing at that point except crash. And so this is why generally we have for loops and while loops and for each loops and do while loops and that sort of thing, because tail call optimization is hard. But so this is some code that is compiled with the .NET framework, the 32-bit version. The 64-bit version of the .NET framework, the JIT, does have tail call optimization. But if you compile it with the 32-bit version, the x86 version, it will just chuck out this code, which will eventually get a Stack Overflow if you start it with a from that's big enough. If you compile it with x64, it does tail call optimization. And you can see down at L0014, it's doing a jump to L0007. So it turns out that a tail call optimization is just a go-to. And I've proved this with the help of SharpLab by writing the same code with a loop label and a go-to loop label, and it literally generates pretty much exactly the same machine code. So yes, when people go, oh, I use a tail call optimized language and I use recursion to represent my logic, you just go, yeah, I use go-tos, so we're pretty much the same when it all comes down to it. Would like to shout out to Andrei Shekin for creating SharpLab, sharplab.io. If you want to see what your C# code is doing, then go and type it into SharpLab. It will show you the IL code. It will show you the lowered C# code where they've done all the sort of async state machines and all that kind of thing. It will show you the and the actual machine code that is produced by the JIT. And it has every version of C# and .NET available, so you can see, if they say, oh, we've improved this from C# 10 to C# 11, you can go and check for yourself and see what they've done to improve it. So yeah, that's a fantastic tool for C# developers. And follow Ashmind on Twitter as well. Okay, I may lose some people on this next one. This is, in my opinion, this is one of the big ones. It's one of the biggest mistakes in the history of programming. Did anyone, Dylan has this fantastic thing where he does this sort of array binary ORed with not array gives you the number 3, and then if you do something and cast it to a string, and you can basically get the entire alphabet out of various string conversions and error messages. And there is an esoteric coding language, which is just square brackets, pipes, and bang symbols. 21 letters. There are 5 letters you can't get out of JavaScript. So yeah, somebody should fix that. But yes, so JavaScript, famously, it was a tech demo for Netscape Navigator 2.0. And somebody stuck their head around Brendan Eich's door, because Brendan was kind of like the programming language. He was interested in programming languages, and he'd written his own Lisp and all this sort of stuff. And they went, Brendan, could you knock up a scripting language that we can stick in the browser so people can make web pages interactive? And he went, yeah, all right. And they went, can you have it ready by next Friday? And he went, what? And so he went and he got the Lisp that he'd written, and he made it work with the document object model that they already had in Netscape Navigator, exposed that as an object that was visible to it, and went back to them and went, how's this? And they went, see, no, because that's weird with all those brackets and things. And there's this hot new thing that people are using for interactive web pages called Java. Could you make it look more like Java? And so Brendan turned it into something that looked more like Java. But then he made various decisions alongside that, like, well, a lot of programmers who aren't used to C-style languages won't want to worry about semicolons, so I'll automatically insert semicolons for them, and various other mistakes, which results in array equals not array does actually return true. And as we saw earlier, if you saw Todd's JavaScript quiz during lunch, array equals array is false. We have this fantastic expression. So what's happening here is we're doing string concatenation, which uses plus, except we've missed something in the middle there. So we've got two pluses in a row. And so what JavaScript actually tries to do there is coerce A to be a number so that it can make it positive. Because if you say, like, you've got a value that's -3 and you say plus A, then it will go, that is now +3, rather than doing math.abs or something like that. And so this tries to make A positive, can't make A positive, returns not a number, and so this expression evaluates to banana. And then you've got the document.all, which was kind of, it was in there in the early versions of things that JavaScript were working with, but in Netscape Navigator and Internet Explorer, it did different things. And so there was kind of a debate. So is document.all an instance of an object? Well, yes, it is. It's an object. So type of document.all therefore should be object, shouldn't it? No, it should be undefined. Okay, so does document.all equal undefined? No, it doesn't. Does document.all equal, does it actually equal null? Does it sort of strictly, with no type coercion, equal null? No, it doesn't. Does it kind of equal null if we use only the double? Yes, it does. Yes, it absolutely does. And the problem is that shipped and people wrote code on it. And so every mistake, every problem that JavaScript shipped with has to be kept, because people have built features on the bugs. Code is out there in static HTML pages hosted on GeoCities or wherever else, and if you change JavaScript, then the internet will stop working. And honestly, I think that would be kind of a good idea some days, but you know, they can't do it. You can't fix JavaScript. You can put in things so you can put like use strict in a string with a semicolon, which is valid JavaScript, but will actually be interpreted by modern JavaScript interpreters to say, hey, turn off some of those old bugs because they were a really bad idea. There is no put in a string, do not use automatic semicolon insertion or ASI off, or anything like that, which means return new line and an object will continue to return undefined. And this, you know, the time that developers spend struggling with JavaScript and going, why won't you fucking work? But at the same time, the laughs we get out of it, eh? The stories we can share in the pub, the quizzes that Todd can put on, the software that Todd can sell. It's extremely good software, and if you're running JavaScript, you really should take a look at it. Track.js, fantastic tool. Cash, right? US dollars as well, not pounds. Those are worth fuck all now. Honorable mentions, Heartbleed, obviously, the OpenSSL library. So the OpenSSL, free, open source, SSL library maintained by a few people who've never made a penny from it. Microsoft are using it, Google are using it, Amazon are using it, Facebook are using it, Apple are using it, everybody's using it. Nobody's giving them any money, nobody's looking over their code, there's a bug in it, and suddenly SSL is complete shit and everybody can steal your credit card numbers. Log4j, quite a recent one. So in Java, you can put in a URI that points to a bean or something, I don't know Java, and Log4j will go and get that fucking bean and execute it. So if you go, right, I bet the thing that I put into this text field here is going to be logged out into Log4j, you can put your malevolent bean on a server somewhere and then put your name in as jbean : / whatever, and Log4j will execute your bean in the context of whatever it is. And Java's ECDSA algorithm, this was actually in the Java runtime until they patched it. So the ECDSA algorithm, you give it 3 numbers plus a whole bunch of weird text, and it says, okay, so if this number multiplied by this number comes out, the modulus is 0, then this is a valid ECDSA key. So if you pass in 0, 0, and 0, I may be getting this wrong. It's something like this. But if you passed in 3 zeros as that key, it would just go, yeah, no, that's fine. I've checked that, and the modulus of 0 and 0 is definitely 0. So yes, other things as well. I will add to this as people sort of tell me about stuff. But I want to finish on the Soviet early warning system. This is one of the things computers do. They keep us safe. They let us know if our enemies are firing missiles at us because they've decided that humanity has had long enough and it's time for it all to end. And this is Lieutenant Colonel Stanislav Petrov. And on the 26th of September, 1983, he was on duty monitoring the computers that checked to see if the United States had launched missiles against the Soviet Union. And suddenly it went bing and said, yes, they have. They've launched 5 missiles. And Stanislav had to go to somebody and say, the Americans have launched missiles, we need to retaliate. But he didn't. He went, seems unlikely that they just launched 5. We know they've got hundreds. If they were going to do it, they'd launch all of them, wouldn't they? They're not just going to launch 5. They're not just going to take out like these 5 cities and then sit there and go, hey, what do you think of that? And so he decided that this was probably a software, and it was a software error. Soviet computers, they weren't great in 1983. You know, we had the IBM PC, and they had some rocks that they banged. I don't know what they had. But whatever, Russians leaving the room now. Going, fuck this guy, he was good for the first hour. So yeah, he decided that he was going to ignore this, and it was actually the sunlight glinting off clouds that had triggered the satellite that thought that those were missiles that had been launched. And so he made that call and basically saved all known life in the universe from complete and total extinction. So thank you, Stanislav. God bless you. That's it for my mistakes. Go back to your homes and make some more. Thank you very much, NDC. Enjoy the rest of your year, and I will see you back here next time.